About 30 years ago, there was no scientific proof of a planet outside our solar system. Technology and science have revealed over 5,300 exoplanets, alien worlds waiting to be explored. Our capabilities have allowed us to discover smaller, Earth-like exoplanets. Initially, these were large gas giants. Welcome back to another exciting video. Today's video is about scientists discover planets more habitable than Earth. Before we start the video, please like and subscribe, and press the bell icon. Scientists have found over 50 exoplanets with Earth-like masses and 800 with radii less than half that of Earth. We know a few planets orbiting in their parent star's habitable zones, where life can thrive, but that's changing. As we search for habitable planets, we're finding planetary systems with multiple potentially habitable planets, including at least one in our cosmic neighborhood. Many compact systems in our Milky Way galaxy revolve around sun-like stars. Planets near these stars are usually too hot for life. However, colder, fainter stars have a closer habitable zone. This triple-star system in Scorpius is Gliese 667, 23 light-years from Earth. Here's the first known system with multiple potentially habitable rocky planets orbiting a low-mass star in its Goldilocks zone. The system has 3 stars like Alpha Centauri. The largest K-type main sequence star in the system is GJ 667a. This orange-red dwarf has 73% mass, 76% radius, and 12% visual luminosity, less than the Sun. GG 667 bits is its 12.5 AU companion. It's a K-type orange-red dwarf with 69%, the Sun's mass and 5% of its visual luminosity. Like Alpha Centauri, the third star is most intriguing. M-type red dwarf Gliese 667c has a third of the Sun's mass and radius. It is faint and cold, with a surface temperature of 3,775 Kelvin. Though small, GJ 667c has a rich planetary system. 3 exoplanets were initially thought to orbit Gliese 667c. They discovered that the planetary system may have 6 planets, with 3 or 4 of them being habitable super-Earths after revisiting data and making additional observations. Exactly what is a super-Earth? The term refers to planets larger than Earth but smaller than gas giants like Jupiter and Saturn. These planets may have atmospheres that support life forms and be rock or rock and ice. The closest planet to the star, Gliese 667 cb, is burning at 200 degrees Celsius. The most massive exoplanet in the system, about 5.5 times Earth's mass, orbits its host star in 7 days and likely has a thick atmosphere. All 3 Gliese 667 planets are farther from their host star and have masses between 1 and 5 times Earth's, making them good habitable candidates. Gliese 667cc, the next closest planet, orbits the star's habitable zone inner edge. With a mass of 3.8 and a radius of 1.8 times Earth, its year lasts 28 days. It is considered the holy grail of extrasolar planets with an Earth similarity index of 0.85. Due to its low energy output, the habitable zone around the red dwarf GJ 667c is located within Mercury's orbit, 0.11 to 0.23 AU from the star. Earth is about 1 AU from the Sun. At that distance, our planet would be an ice world orbiting star C. Gliese 667cc orbits its parent star, the red dwarf, every 28 days, 8 times closer at 0.12 AU. Due to its proximity, the exoplanet may be tidally locked to the star, with eternal day and night on opposite sides. Drastic temperature differences between the 2 sides may affect the exoplanet's global climate. Gliese 667 receives about 10% less sunlight than Earth, but since most of its light is infrared, it receives about the same amount of energy from the Sun, which would help retain water on its surface and create a similar climate. The surface temperature of Gliese 667cc cannot be predicted because scientists don't know if the planet has an atmosphere or how thick it is. An Earth-like atmosphere would transfer heat and equalize temperatures across the planet, making the night side 30 degrees Celsius. A planet like this would be different to live on. The star gives GJ 667cc, a faint red glow. The other two stars, Gliese 667a and b, are 230 AU away, outside the planetary system, and farther than Pluto and the Sun. However, the two other suns would appear as bright stars during the day, and as bright as the full moon at night, while our Sun would appear as a distant star. Unfortunately, the nearby red dwarf emits bright bursts of radiation and energetic particles up to 1,000 times stronger than those on our Sun. Located near its flaring host star, Gliese 667cc may pose challenges for potential life. The red dwarf's strong magnetism may cause star spots, reducing energy output by up to 40% for months. Additionally, the lack of ultraviolet light emissions may hinder life formation. Gliese 667cc is so big, living there would be different. Higher mass means different gravitational acceleration on the exoplanet's surface. One weighing 75 kilograms on Earth would weigh 120 kilograms on Gliese 667 kT. Larger planets' atmospheres increase surface pressure. Earth's atmosphere has only a few times more pressure. A planet's Venus-like atmosphere may have hundreds of times Earth's deep ocean pressure. Habitable Gliese 667 may not be Earth-like. Low light, atmospheric pressure, and flares can shorten Gliese 667cc life. Such a world sustains life. Life on Earth adapts well. Similar planets may be habitable. Due to their distance from their planet's star, Gliese 667CE, 667CF receive less energy. It could freeze and kill. Thick atmospheres would warm these planets and allow life instead of Gliese 667cc. 3 such worlds are rare in a planet's habitable zone. 4 is unlikely. A study found that 5 Gliese 667c planets receive 20 to 200% of Earth's solar radiation, making them habitable. Numerous factors contribute. 2 habitable zones for Earth-mass planets were found around Gliese 667c. The inner boundary is 0.095 to 0.126 AU from the star, and the outer boundary is 0.241 to 0.251. Any planet orbiting star C at these distances may support life due to its liquid water. Inhabitable planets near stars evaporate water due to heat. Water vapor raises temperatures as a greenhouse gas. Only planets with a larger mass at the habitable zone's inner edge resist the moist greenhouse effect. Remote Gliese 667g risks ice. CO2 prevents this by warming the planet, but too much cools it by reflecting light. So CO2 can only warm the planet so much. Gliese 667c had 6 planets and possibly G667ch by 2013. Although controversial, the exoplanet between planet C and B may be the smallest around star C, with a mass at least 1.1 times Earth's. Planet H is too hot for life due to its mass and proximity to the parent star. The habitable zone is confirmed for F and E, but D's orbit is uncertain. Instead of 10 stars, one has Earth 2.0 candidates. Our understanding of the universe is expanding exponentially as telescopes improve. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.